This is the first of 3 videos that I'm making that are covering how to solve radical equations. In this particular video, I'm just going to set up some basics on something that you're going to need to know about whenever you solve any equation in this chapter. So 5.3.0, our first lesson, is about something called restrictions. And so something that's really important to know is that any time that you are going to be solving a radical equation, anytime you have an equation that involves a variable inside of a root, our equation won't always work. There are going to be some values that aren't allowed. And so in this video, I'm just going to kind of go over why those exist and how to figure out what they are. So we have to limit the values that our variables can take. And so think about roots and what numbers you can and cannot have inside of roots, and you might be able to figure out sort of where these restrictions come from. We're going to pretty much always be working with square roots, and so the key thing to think about is that we can't have negative values inside of a root. Specifically, we can't have a negative radicand. So you could see a negative inside the root and still have it work out if maybe a couple of negatives end up canceling out or something like that happens. So don't just see a negative and automatically think something's wrong. It's going to be that when the entire radicand is negative that things don't work. So to start with the most basic possible example, if we had just the square root of x, well, x can't be negative. It is our radicand. It is the entire thing. And so what we'd say for our restriction is that x has to be positive, right? So the easiest way to write that is to say that x is greater than or equal to 0. 0 works. Anything positive will work. Anything negative won't work. Most of the time, though, our radicands aren't just going to be x. There's going to be stuff going on inside when we're trying to solve these equations. So let's look at something a little bit more complex. Maybe, let's say, root x plus 2. So still not a whole lot going on. And so x can be negative here. If you stop and think, there are a couple of negative values that we could plug in, and this would still work out. Say, like, negative 1, for example. If x was negative 1, negative 1 plus 2 would be positive 1, and that's totally fine. So the way we're going to do this, to find your restrictions for any equation in this chapter, it's a pretty simple process. You're going to take the radicand, which in this case is x plus 2, and you're just going to do what we did on the last example and set it greater than or equal to 0. And then you just have to solve. So in this case, that means we have x plus 2 has to be greater than or equal to 0. Right, so that's our radicand, greater than or equal to 0. And then we just solve this the same way we solve equations usually. So we're going to subtract 2 on both sides, and we get that x has to be greater than or equal to negative 2, which makes sense, right? Like we said, negative 1 would work fine, 0 works fine, but something like negative 3 won't. So let's try another. So we're going to find the restrictions for a slightly more complicated one now. Just a little bit. Square root of 2x plus 5. So the first thing we need to do, again, is take that radicand, 2x plus 5, set it greater than or equal to 0, and then just start moving stuff around. So remember, when you're solving, you want to deal with adding and subtracting first. So we're going to start by getting rid of that 5. Which is going to get me 2x is greater than or equal to negative 5. And then we just divide by 2. And so x is greater than or equal to negative 5 over 2. And there we go. And so you're going to do this every single time you solve an equation. Every time, no matter what. It is mandatory. So I'm going to give you a couple of these to try out for yourselves. So give these ones a shot. Pause the video once you're ready to go. Try them out, and then come back and see how you did. All right, so the one on the left is pretty simple. right? So 3x greater than or equal to 0. We're going to divide both sides by 3. And we get x is greater than or equal to, well, 0 divided by 3, which is still just 0. Which makes sense, right? So 3 is a positive. You can't put a negative in there, because if you put a negative 3 times the negative will get you a negative radicand. For the one on the right, remember, it is just the radicand that we care about. So that 4 and that 8 do not affect this restriction at all. It's still just the 3x minus 12. So we're going to take that, set that greater than or equal to 0. Going to add 12 on both sides, which gets me 3x is greater than or equal to 12. We're going to divide by 3. And that gets me x is greater than or equal to 4. Great. This next one is going to look pretty much the same, but there is going to be something extra here that we have to be careful with. So we've got negative 2x minus 8. So if we go through our steps here, we've got negative 2x minus 8 is greater than or equal to 0. I'm going to make a mistake intentionally in what I'm about to do, so don't copy it down just yet. Just follow along, and then I'll tell you once we fix it. So we've got negative 2x. We're going to add 8 on both sides. So we're going to get negative 2x is greater than or equal to 8. We're going to divide both sides by negative 2, which gets me x is greater than or equal to negative 4. But let's think about a number that would fit this. So let's say we did x was positive 1. That's definitely bigger than negative 4, right? But if we put positive 1 into this, negative 2 times positive 1 minus 8 would get me negative 2 minus 8, which is negative 10. That's definitely not a positive radicand. So our restriction doesn't seem to be working here. Something's gone wrong. If you think back to Math 9, when you did your inequalities unit, you may remember that there was something special about what we just did. And it happens in these two steps. So I'm going to erase just one thing in our answer. What's going on here is that when we divided both sides by negative 2, there was something else that we should have done, and that was flip our inequality around. So this inequality, which was facing to the left, now needs to be facing to the right. And that's going to happen anytime you multiply or divide both sides of an inequality by a negative number. So in this case, we divided both sides by negative 2. And that should have flipped our inequality. And so that's the one thing you really have to keep track of. So now everything's fixed, and you should be able to start copying things down if you're taking notes. So just make sure to keep track of this. It's a really common mistake, and it will get you very wrong answers. So again, anytime you multiply or divide both sides by a negative number, you flip your inequality. And just for a really quick example of that, right? If you had, say, 4 is less than 5, right, which I think we'll all agree is true, if you multiplied both sides by negative 1, you'd get negative 4 and negative 5, right? And so you can tell just by looking at that the inequality should be facing the other way. Negative 4 is bigger than negative 5. So keep track of that. It's something that will come up fairly frequently when you're solving these things. So just make sure you're flipping when you need to. All right, a few last quick edge cases of things that won't really come up too much for us in this course, but just something to be aware of. Square root of x squared. So if you think about this, remember we want our restrictions to be things where the radicand is positive, right? So we only want positives. But x squared will always be positive. No matter what you put in there, if you square a positive or a negative, you're still going to get a positive answer out of it. So that has no restrictions, which can happen. That's not to say that all quadratics would have no restrictions. If this was, say, x squared minus 1, we would definitely have some restrictions. But that's something that we're going to get more into in probably chapter 9, so we're not going to sweat it too much right now. If this was a cube root, automatically, no matter what's on the inside, we've got no restrictions. because cube roots can take positives, cube roots can take negatives. So there's no issues here. But again, we're not going to deal with solving cubic equations, so don't sweat it too much. And there you have it. So these restrictions are something you're going to do in every question for all of 5.3 for any time you're solving radical equations. So make sure that you got a handle on them because you're going to be doing them a lot. In the next couple of videos, we're going to start looking at how to actually start solving radical equations. So once you're ready, move on and see how that goes.